In this video, I'd like to take a look at quadratic functions. We've already taken a look at quadratic equations in this playlist, but now we're going to rewrite those equations as function formulas, right? A function is a special type of equation because it's essentially a set of instructions that tell you what the operation is doing to the input to get the output. Okay? So let's get started with quadratic functions right now. Okay, here we go. Quadratic equations recap. We're going to go through a review of some things we've already seen in this playlist. Let's revisit the definition of a quadratic equation. An equation containing a second-degree polynomial is called a quadratic equation. Remember, the degree of a polynomial is the highest power that occurs, so these are all examples of quadratic equations because of this power 2 here, here, and here. Okay? Consider the equation that contains a second-degree polynomial right here, where a, b, and c are real numbers. If a is not equal to 0, then this equation is in standard form. All right, this is the standard form of a quadratic equation. X is the variable that we're solving for, and a, b, and c are just parameters, right? Those are just constants. We learned 4 methods for solving quadratic equations, right? There's factoring, using the square root property, completing the square, and using the quadratic formula. Okay? These 2 methods right here, these actually require that the equation is in standard form. Okay, so that's kind of interesting. And here's my advice when solving quadratic equations, right here. When a equals 1, we need to try factoring, right? We can factor the left-hand side and then use the zero product property. And we want to use the square root property when the problem looks something like this, right? If we have a quadratic equation that looks like this, we can just take the square root of both sides right away and isolate x. And we complete the square only when the problem specifically asks us to use that method. All right? And finally, use the quadratic formula when a does not equal 1. When the lead coefficient is something other than 1, just use the quadratic formula. Okay. What happens when we involve y in the equation? Right here we have the equation y equals x squared plus x minus 6. This equation is represented by this curve, right? Every single point that occurs on this curve is a set of x and y values that satisfy this equation up here, right? If we plug in this x value and this y value, we'll end up with a true equation. Something like 3 equals 3. Okay? The graph of a quadratic equation is a curve called a parabola, right? That's what this curve is called. And check this out. When we solve the equation x squared plus x minus 6 equals 0, we're setting y equal to 0, right? We're taking this equation here and we're setting y equal to 0, which means when we solve this, we're actually finding the x-intercepts of the parabola, right? Remember, these points here on the x-axis, they have a y value of 0, right? Because they have a height of 0. So when you set y equal to 0 and you solve for x, you're finding the x-coordinates of these blue points here. Okay? That's essentially the bread and butter of quadratic equations. Now we're ready to move on to the new material. Let's break down the anatomy of a parabola. Okay, let's take a closer look at this curve. This point down here is called the vertex. The vertex is the extreme point. If the parabola opens upward like it does here, then the vertex is the absolute minimum. All right, recall the difference between local and absolute maxima and minima from the behavior of graphs video. I'll include a link in the description. So if the parabola opens upward, the vertex is the absolute minimum. But if the parabola opens downward, then the vertex is actually the absolute maximum. Okay? So the vertex is a special point that we want to hone in on and analyze. This blue dashed line here is called the axis of symmetry. Okay? The parabola is symmetric about the vertical line passing through the vertex. This vertical line is called the axis of symmetry. Okay? Recall from the even and odd functions video that we looked at the graph of y equals x squared, and we found that it was symmetric about the y-axis. So that's what made it an even function. But, fun fact, all parabolas are symmetric about some axis, right? It just depends on where it's located. So it's symmetric about this line, and this is important here. The blue dashed line passes through the vertex, okay? And the y-intercept here, this green point, this is the point at which the parabola crosses the y-axis. All right, this is fairly straightforward to find. All you have to do is plug in x equals 0 and evaluate the function to get the y value, and you'll have 0 comma something, right? In this case, we have 0 comma -3. So that's the y-intercept. And the x-intercepts are given by these red points, and these are harder to find. It's a challenge to find these. The x-intercepts are the points at which the parabola crosses the x-axis. Okay, so that's where y equals 0. They're at a height of 0. The x-intercepts are also called the zeros, or the roots of the function. Okay? We'll get into this more in the next video. I want to talk about intercepts in the next video. So let's talk about standard form. The standard form of a quadratic function is given as f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and a does not equal 0. Okay? If a is positive, right, if a is greater than 0, then the parabola opens upward. If a is negative, then the parabola opens downward. All right? So if it's in standard form like this, we can just look at the equation. We can just look at this number a and determine some characteristics about the parabola. Okay? And the axis of symmetry is given as x equals minus b over 2a. Remember, the equation of a vertical line is x equals something, right? X equals some number. And we can actually prove this. We can prove that the axis of symmetry is given by this equation a few different ways, right? I've seen 3 different proofs. 2 of them involved some messy algebra, and the third involved calculus. Okay? We're not going to prove this equation in this video, right? I'm going to skip the proof for the sake of brevity, but I do want to make a video in the future showing you guys all 3 methods that you can use to prove that the vertical line, the axis of symmetry, is given by this equation here. Okay? And remember, the axis of symmetry passes through the vertex. So this equation here immediately gives rise to something called the vertex formula. Okay? Given a quadratic function in this standard form, the axis of symmetry is given by this equation here, x equals some number. Okay, minus b over 2a is just going to collapse down to some number, and we'll get x equals something. So the vertex is located at minus b over 2a, comma, f of minus b over 2a. All right? So because the axis of symmetry passes through the vertex, that means that we know what the x value of the vertex is. Okay? It's minus b over 2a. And then to find the y value, we just plug that number into the function. Okay? Let's do that right now. Here we're asked to graph the quadratic function f of x equals x squared plus 4x plus 3. Okay? The first thing we notice is that we have a equals 1, right? There's an invisible 1 right here as a coefficient. A equals 1, b equals 4, and c equals 3. Since a is positive, that means that the parabola opens upward. Okay? And the axis of symmetry is given by this equation here. Okay, it's minus b over 2a. So let's plug these values in to find the axis of symmetry. All right, b in red is 4, and a in blue is 1. Okay, so this is what we have when we plug in those values. And we get minus 4 over 2, which is equal to negative 2. Okay, that's the axis of symmetry. Let's go ahead and plot that right now. This is the axis of symmetry. Okay, it's this blue dashed line. So we know where the axis of symmetry is, and we know that this parabola opens upward. So let's use the vertex formula to find its location. Okay, the axis of symmetry always passes through the vertex, right? No matter what quadratic function you have. So we found its equation, right? We found that its equation is x equals negative 2. So if we plug that value into the function, we can get the y value of the vertex. Okay? So f of negative 2 in purple here is equal to this, right? The function says to take what you're given and square it, and then add 4 times what you're given, and then add 3. So we'll take negative 2 and square the whole thing, and add 4 times negative 2, and add 3. That gives us 4 minus 8 plus 3. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. Okay? So we just found the y value of the vertex. It's this purple point here. It's located at negative 2 comma negative 1. This is the x value that corresponds to the axis of symmetry, and this value is what we get when we plug that x value into the function here. All right? Next, what I'm going to do is just tell you that the x-intercepts are here and the y-intercept is up here. All right? I'm skipping the algebra for the sake of brevity. But stay tuned, right? In the next video, we'll talk about intercepts in more detail. So look at these points here. We have enough info to graph this curve now, okay? This parabola passes through all 4 points, and this is what it looks like. Okay? Next, I want to talk about something called the vertex form of a quadratic function. The vertex form is given as f of x equals a times x minus h squared plus k, where a does not equal 0. And the vertex is given as h comma k. Okay? So if the quadratic function is in this form, we can just look at the equation and immediately declare what the vertex is. Okay? So this form is really cool. If it's in standard form, you have to use the vertex formula to find the vertex. And as we just saw, that takes a lot of work. But if the equation is in this form, we can just look at it and say the vertex is h comma k. Okay? Let's see a couple examples. Here we have f of x equals 2 times x minus 3 whole thing squared plus 4. All right? We have a equals 2, and h equals 3 in blue here, and k equals 4 in red. So we can just look at this equation and immediately write down the vertex, and it's at 3 comma 4. Okay? We have to be careful with this formula though. It's really easy to make a sign error. All right, let me show you what I mean. Let's look at another example. If we have something that looks like this, this is in vertex form, but we have to be careful. All right, I'm going to rewrite this as negative 5 times x minus negative 6. Okay, why am I doing that? It's because this subtraction is baked into the form here. All right, so instead of having plus 6 here, we can write it as x minus negative 6, and we can recognize that h in blue is negative 6. Okay, so just be careful of that. All right, watch out for sign errors. It's really easy to make sign errors in algebra. It's the most common type of error. So watch out for that. Okay. H is -6 in blue, and K is -7 in red. So the vertex is located at -6, -7. Okay. Next, let's talk about the domain and range. The domain of any quadratic function is all real numbers. Okay, it's -infinity to +infinity. We can plug any number we want into the quadratic function. Okay, so it's all real numbers except for when the problem states that the domain is restricted. Okay, for example, if the independent variable is time, often we restrict that domain to positive numbers, right? It only makes sense to have positive time. So when we're working on word problems, let's just pay attention to domain restrictions if there are any. Okay, otherwise the domain is all real numbers. The range of a quadratic function, written in standard form, right here, ax squared plus bx plus c, with a positive a value, is given by this set here. Okay, this is a set written in interval notation. Okay, if the a value is positive, that means that the parabola opens upward, which means that the vertex is an absolute minimum. So the y value starts here, right? It starts at f of this value, and it continues up to positive infinity. Okay? But if the a value is negative, that means that the parabola opens downward, and the vertex is an absolute maximum, which means that the y values are going from -infinity up to this value, right? F of minus b over 2a. All right? So if the quadratic function is in standard form, we have to do a little bit of computation to find this value, right? We have to find out what minus b over 2a is and plug it into f to get that value. But if the function is in vertex form, like this, and we have a positive a value, we know what the coordinates of the vertex are, right? It's h comma k. And we have a positive a value, so the parabola opens upward, so we have an absolute minimum, which means that the y values are going from k to positive infinity. All right? And if we have a negative a value, that means that the parabola opens downward, and the vertex is an absolute max. So the y values are going from -infinity up to k. All right? To close the video, I want to talk about maximum and minimum values of quadratic functions. All right? Let's take this curve here, right? It's written in vertex form, so we can say right away what the vertex is. We know that it's h comma k, so in this case it's 2 comma 1, right? We have 2 in blue and 1 in red. So the vertex is the absolute min, which means that the minimum value of 1 occurs at x equals 2. Okay? When we work on word problems and they ask us to find the max and min values, they're talking about the y values. All right? These are the values that the function spits out. It spits out a minimum value of 1, and it can the range goes from 1 up to positive infinity. Okay? So the minimum value is 1, and x equals 2 is just the location. All right, this is the horizontal position of the vertex, and we can see that in this case it's x equals 2. All right? And then if we have a curve that looks like this, we can see that a is -1, so a is negative, so this parabola opens downward, and it's in vertex form, so right away we can just write down the vertex. Right, it's 3 comma 4 in this case, 3 in blue and 4 in red. And that means that the maximum value of 4 occurs at the position x equals 3. Okay? We'll work on some word problems in a future video where we're asked to find maximum and minimum values. Okay? That does it for this video. Thank you for watching, and like and subscribe.